Hi students, I'm Dr. Z and I work with the Children's Science Center, and this is one of the Do-It-Yourself series. Today I have a scientific puzzle that maybe you and I together can solve, and it's something that it's not too hard for you to do at home actually. But before we start on it, we need a little science lesson. You know, a long time ago, scientists realized that all of us on the earth live at the bottom of an ocean of air. Isn't that a wonderful idea? We live at the bottom of an ocean of air. As you well know, air completely surrounds our whole planet. And even though air, you can't see it really, you don't seem to feel it much except when the wind blows, you feel the air. But the thing about air is that if you look up, it goes up 5 to 7 miles above us. So that's a big ocean bearing down. And the weight of all that air actually exerts a force or a pressure on all of us, on everything. And this air pressure can have a big effect on our weather, especially, even sometimes the way we feel, depending on the changes. The air pressure can change. Okay, keep that in mind as we try to solve our little scientific problem here. I have a bottle here, and I have, as you see, a balloon blown up inside the bottle. And the puzzle is, how did I get that balloon in that bottle, okay? Obviously, I didn't blow it up outside and try to stuff it back in there. I don't think that would work very well. So how did I do that? What? Oh, someone mentioned that maybe if I take an empty bottle and I take my balloon, okay, and I stuff it inside, empty inside the bottle, okay. Science doesn't always go right. Let's get that in there. And then if I take the end of the balloon and put it around the top of the bottle, you see now I have a nice hole in there. So theoretically, I should be able to blow this balloon up and then just tie it off and we'll have our balloon in the bottle, right? Right. Oh, wow. I'm getting dizzy. As much as I try, I cannot blow that balloon up in the bottle. I wonder why. Oh, wait a minute. I forgot. My wand of scientific knowledge. 3 taps. Okay, let's see if I can do it now. Okay, as you can see now, I was able to blow that balloon up. I could do it even more if I tried. And then I would just tie it off and let it fall into the bottle, and I'd have my balloon in the bottle. Okay, so all you need then is your wand of scientific knowledge. Nah, I'm just teasing. I don't have any special wand, but I do have something called scientific knowledge. And here's the thing, remember we were talking about air pressure? Well, when you start out with your empty bottle, it's obviously full of air, right? And air pressure works in all directions, up, down, to the side. And the air in that bottle is exerting a certain amount of pressure out. At the same time, oops, I knocked over my sign. At the same time, the pressure is working on the bottle from the outside. So the two are what we call in equilibrium. But here's the thing. If I go ahead and start trying to blow that balloon up, the balloon is going to get bigger and should get bigger and bigger, and it's going to fight against all the air that's already in the bottle. And that air pressure is resisting. It doesn't want to move, so it doesn't allow me to blow up that balloon. So how did I do it? Well, I kept a secret from you. Earlier, I took a nail and I punched a hole in the bottle, right? See, that there? Can't even see it, right? And when I tried to blow the balloon up, I put my finger over the hole, right? So as much as I would try, I could never blow that balloon up. But when I take my finger off of it, now when I blow the balloon up, the air that fills the balloon is pushing the air in the bottle out through that hole, and that allows me to blow the balloon up, and that's how we can get our balloon in a bottle. Kind of neat, huh? And you can do this at home and amaze your friends and your parents, okay? One last thing, just as the air has pressure, so does water. If you lived at the bottom of the ocean, the weight of all that water on top of you would be tremendous. It's very, very strong. Okay, so here's an interesting experiment. Again, you can do it at home. This is just a regular water bottle. I have it completely filled to the top with water. This is a medicine dropper, okay? You probably have these at home, or you can get them at the drugstore. It helps you pick up liquids for distribution. You can see I painted some blue on the medicine dropper to make it look so we can see it a little better. So what you do is you take your medicine dropper and you fill it up about halfway with some water, okay? And then you just bloop, let it fall into the water, and you put the top on real tight, okay? And now I have a magic string at the bottom here, and as I pull the string, wow, the medicine dropper falls to the bottom. If I let the string go, it goes to the top. See that again? String pulls it down, and then I let it go. Okay, you know that I don't have any magic string in here. What I'm doing is, maybe you can't see, is when I want the medicine dropper to fall, I squeeze on the bottle. And then if I want it to go up, I let it go. And if you watch carefully in that medicine dropper, when you squeeze it, you will see the level of water is increasing. That's because as I squeeze this water, the extra pressure I'm adding to the water pushes water up into my medicine dropper, and it makes it heavy enough that it sinks. And when I let it go, the water comes out of the medicine dropper, and it's lighter, and it floats to the top. This is something called a Cartesian diver, and again, it's something easy to make at home and lots of fun. Okay, guys, keep doing science. Until next time, take care. Have a good day.